All right, so hello everyone. Hope you had a nice weekend. Today we'll be moving on to part 3 of our trig equation series. Your aim for today is how do we solve trigonometric equations with multiple angles, and the do now is an example of that. So here we have 2 sine 3x minus 1 equals 0. Part A, we're going to first solve for all real numbers, and then part B, which is what we're going to look at today. So, part B is like an example of the type of question we'll be solving today. Um, that'll be from 0 to 2 pi. Okay. But actually, I'm going to jump into the solution itself. So yeah, don't worry if you didn't get to it yet. I'm going to just jump up to solution for this do now. Okay, so here we have sine 3x is 1/2. So, as we did last week, we're going to isolate the trigonometric expression. After that, we're going to use this thing called, u substitution. I know the variable here isn't u, but it's like theta we're using here. But it's the same method we saw last week in one of the homework questions that I went over briefly. But yeah, you're going to see it again next year in calculus. Just an algebraic way to solve equations sometimes when you have like either a squared expression or a coefficient in front of your variable, as we do in this case. Okay, so we have let theta equal 3x. So this equation will become sine theta is 1/2. And from there, you should realize that the angle theta is going to be 30 degrees or 150 degrees, right? So theta is pi over 6, right? That's 30, or 5 pi over 6, that's 150 degrees. And then, since we're solving for all real numbers, to generalize for all solutions, we add 2k pi. Right? If you remember from last week, that's like, adding 360 degrees, 720, 1080, etc. And also like negative 360, negative 720, etc. Okay, after that, you're going to plug back in, 3x. So substitute that back in. And then so 3x equals these two expressions. And then if you divide both of these by 3, then you're going to get our final solution, which is pi over 18 plus 2k pi over 3, as well as 5 pi over 18 plus 2k pi over 3. Okay, so that'll be your final answer for part A. And I'll pause right here so you can copy it down. And then after that, we'll move on to part B. Okay, does anyone still need the solution for part A? Gonna type in the chat or speak up. All right, if not, I'll move on then to part B. So part B, we're solving from 0 to 2 pi. So it's a finite, number of solutions. And, this is the new part of today's lesson. So when we're solving on 0 to 2 pi, right, what we're going to do is actually plug in, specific values for k, right? So last week, some of you have asked me questions about like what does k mean. Today we'll actually like see like how it comes up. So yeah, like k is an element of z, and actually I should type that in here. So k is an element of z, right? That means k is an integer. Okay, so like -1, 0, 1, 2. Yeah. Now note here that we're gonna start at 0, not -1 or like negative numbers, because our lowest value should be 0, right? So we don't want negative angles here. So we want to start with positive values. All right, anyway, we're going to plug in k equals 0. If we do that, then if you plug in 0 here, then you're going to get pi over 18 plus 2 times 0, pi over 3. And then, this is just 0 here. So it'll just be pi over 18 for your first answer. And then that's going to be followed by 5 pi over 18 plus 0, which is 5 pi over 18. So those are our first two answers. Then we let k equal 1. So that'll be pi over 18 plus 2 times 1 pi over 3. And at this point, we want to combine the fractions. So we're going to multiply this fraction by 6 over 6. So we get 12 pi over 18. Okay. So if you do that, you get 13 pi over 18. For the other expression, 5 pi over 18, you're going to add the same thing, right? 5 pi over 18 plus 12 pi over 18. That'll be 17 pi over 18. And then lastly, we have k equals 2. If you do that, you're going to get pi over 18 plus 4 pi over 3. If you multiply 4 pi over 3 by 6 over 6, you get 24 pi over 18. And in sum, you'll get 25 pi over 18. And then for the other expression, you get 5 pi over 18 plus 24 pi over 18. That's 29 pi over 18. And then note that this is where we stop, right? So when I write here that, when k equals 3, then we have pi over 18 plus 6 pi over 3. Well, 6 pi over 3 is 2 pi, right? But that exceeds our range that we want, right? So our max value that we want would be 2 pi, not inclusive. But if k equals 3, then that already exceeds 2 pi, right? So we don't, k equals 2 is going to be our last k value, okay? So yeah, those are our 6 answers for part B of this question. Pi over 18, 5 pi over 18, 13 pi over 18, 17 pi over 18, 25 pi over 18, and then 29 pi over 18. All right, so that's our Arduino. All right, I'll give you a sec to copy that down. All right, does anyone still need the solution here? Okay, if not, then I'll move on to the next example. All right, for this one, we have solve the equation square root of 3, 10 of x over 2 minus 1 equals 0. And first, we're going to solve over r, and then part B, we're going to solve from 0 to 4 pi. Note that the interval in part B is different from the do now, right? In the do now, we have like 0 to 2 pi. Here we have 0 to 4 pi, which is a little different, but, yeah, nothing, I won't make it like more complicated. It's just something we have to watch out for. Okay. All right. Part A, we're going to solve, the trig expression, and we're going to add like 2k pi, etc. Right. So we have 10 of x over 2 equals 1 over root 3, right? So that's when we isolate this trig expression, add 1 on both sides, and then divide by square root of 3. We get, 10 of x over 2 equals 1 over square root of 3. From there, we're going to multiply top and bottom by root 3 over root 3. We get root 3 over 3. And then at this point, you should realize that this angle, x over 2, whatever x is, well, x over 2, we know that to be 30 degrees, right? And in case you don't remember, right, like, so if you don't remember which angle gives us a tan value of root 3 over 3, you can always use your calculator. Just make sure your calculator is in degree mode, and you'll get 30 degrees, right? So arctan of root 3 over 3, that gives us 30. The other angle is going to be 210, right? Because tangent is positive in quadrant 3. So it's 180 degrees plus another 30. That's 210. Okay, so that's our two answers here, pi over 6 or 7 pi over 6. And we're going to add 2k pi to both, right? Because, a full rotation will give us the same location or the same answer. Okay, but note here that I summarize this as, pi over 6 plus k pi, right? So instead of adding 360 degrees, I'm going to add 180, right? So from 30 degrees, if I add 180, you're going to get here, right? And then if you add another 180 to 210, you're going to end up at this location here. Right. Well, 180 plus 210, that's 390, right? So yeah, you're going to end up at the same location as 30 degrees. So yeah, this can be summarized as pi over 6 plus k pi. Okay. All right, and then from there, we're going to solve the angle. So we have x over 2 equals pi over 6 plus k pi. So remember, our goal is to solve for x. So I'm going to multiply both sides by 2. You get pi over 3 plus 2k pi. Okay, so our final answer is going to be summarized as pi over 3 plus 2k pi, where k is an element of z. All right, that's part A. All right, is anyone still copying part A? Otherwise, I'll start talking about part B. No? Okay, all right. For part B, so here, remember, we're solving from 0 to 4 pi. So, just like the do now, we're going to plug in specific values, and, we're going to use the part A answer. So for all these questions, so I know this is a new topic, so it's okay if, you're a little confused at first. I was too when I first learned this. But yeah, so the procedure here is like solve for all general solutions, come up with this uh, pattern that describes it, like pi over 3 plus 2k pi. And then, when they want you to solve under a specific range, like 0 to 4 pi, then you just plug in the k values. Okay. All right, but yeah, that's what we're going to do here for part B. So first you let k equal 0, so that will be, pi over 3 plus 0, which is pi over 3. And then if you let k equals 1, then that'll be pi over 3 plus 2 pi. 2 pi can be rewritten as 6 pi over 3. So that'll be 7 pi. Sorry, k equals 2. If that happens, then x will be pi over 3 plus 4 pi. Well, that exceeds 4 pi, right? Because it's 4 pi plus pi over 3, right? So these are going to be our only two answers. Okay, so pi over 3 as well as 7 pi over 3.
I have a question about part A. Would the answer still be correct if you hadn't summarized your answer using just pi over 6 plus k pi? Like if you also used 7 pi over 6 plus 2k pi and like divided that by 2, would that still be part of the answer?
Yeah, that would be okay. Well, so in both cases, we're gonna multiply by 2, and then for part B though, that's gonna make, so the reason I summarize this, like remember, like last week I said you didn't have to, and it's true you don't have to, like, to get the correct answer, but like it'll make your life easier, especially in these questions, because like if you don't summarize it in one equation, then you're gonna substitute for like 2 equations at a time, and that'll be more difficult. Well, it just like requires like a little more writing, but yeah, that wouldn't be wrong.
Okay.
Yeah. So yeah, like for this one, for example, like you get x equals 7 pi over 3 plus 4k pi. So in the part B, that will be like if k equals 0, then you get 7 pi over 3, and that'll give us this. But then you wouldn't be able to do like 7 pi over 3 plus 2 pi. Right? Yeah, that'll be 13 pi over 3, which is over 4 pi. So, yeah, all right, that's this answer, k equals 2. All right, anyone still copying this example? Or any questions of it? Okay. All right. So let me go through the first question on the classwork. Okay, and then I'll stop after this question. All right. So questions 1 and 2 on the class we're going to solve on R. So we don't have to do like the k equals, plugging k specific k values. We're just going to find the general solution. All right. First thing I do is I'm going to let theta equal 9x, right? Because I don't want to. Yeah, it'll be easier to work with this equation if you do that. You're going to get 10 to the fourth power of theta minus 9 equals 0. And then from there you factor, right? There's a difference of squares, right? Like, a squared minus b squared. You can factor that as a minus b times a plus b. Right, same thing we do here. So we're going to get 10 squared theta minus 3 times 10 squared theta plus 3 equals 0. And then from this equation, right, 10 squared theta plus 3, we actually get no solution, right? Because 10 squared theta equals negative 3. Right, it's no solution because a squared number, right, this 10 squared theta, is always positive, just like this class. So, you can't get a solution from this, right? Because, or you can also see it as like, if you take the square root of both sides, then you get, tan theta is square root of negative 3, right? That's an imaginary number. So here we're solving for real numbers only. So yeah, that would just be no solution for this. For the other equation, we get tan squared theta minus 3 equals 0. Add 3 to both sides, you get, tan squared theta is 3. Then you take the square root of both sides. Okay, so tan theta equals plus or minus root 3. And then at this point, you should realize that the angle theta is going to be 60 degrees and 240, right, for the positive root 3. And then for negative root 3, it's going to be 120 degrees and 300 degrees, right? Because remember, tangent is positive in quadrants 1 and 3, negative in quadrants 2 and 4. Okay. All right. But yeah, from there, I summarize that as theta equals pi over 3 plus k pi. So pi over 3 plus k pi, that comes from, the positive solutions, right? So pi over 3 is 60 degrees. And then if you add pi, you get the other positive one. And then if you add pi again, you get back to this one. Okay. For 2 pi over 3, you get, so that's 120 plus pi. That'll be like from here to here, right? And then if you add pi again, you get back to the quadrant 2 answer, right? So this can be summarized as pi over 3 plus k pi and 2 pi over 3 plus k pi. Note here, you can always, if you want, you can write this as 4 separate answers. So you do like pi over 3 plus 2k pi, 2 pi over 3 plus 2k pi, etc. But I find it easier to just summarize it, and then you have 2 equations. All right, after that, you're going to substitute back in, right? So substitute 9x for theta, and then you're going to get 9x equals pi over 3 plus k pi. And then from there, remember we're solving for x, so divide both sides by 9. You get pi over 27 plus k pi over 9. And then the other equation, you get 2 pi over 27 plus k pi over 9. Okay, so that'll be our 2 answers here, which you see in the last line of the solution. Okay, so pi over 27 plus k pi over 9, as well as 2 pi over 27 plus k pi over 9, where k is an element of z. All right. Does anyone still need to copy this solution here? Okay, if not, then, so that's actually all the work I wanted to go through today. We only have like 2 minutes left, so I'll go through the other questions tomorrow. And for closing announcements, just regarding the quiz. So remember, our next quiz is this Friday. The topics list is on Google Classroom, and this will be the last topic on that quiz. I mean, the next lesson is another like unique lesson. It's a new lesson, but it's just like practice with these trig equation questions. So, not a new topic. But yeah, this will be like the last new topic on Friday's quiz. Secondly, I did make a practice quiz on Alex. So the practice quiz has like 10 questions. The real quiz, though, it'll have like, I think it was 6 questions. So it's shorter than the practice quiz, but the practice quiz is just to like review the various topics. So please, yeah, just please make use of that resource. It's good practice, to do your best on Friday. Okay. Third, there is SGI today at 2:47 per usual. You can drop by if you have questions on yeah, this lesson or any homeworks or etc. But yeah, 2:47. Let me know. Okay. Yeah, that's all I want to say for today. I'll end us a minute early, but yeah, if you have no further questions, you're free to go, and I'll see you tomorrow. All right, take care.
Have a nice day.
All right, thank you too.
Thank you.
Have a good
Welcome.
day.
Thanks, you too.